In Marvel, Doctor Strange had a time stone where he could reverse time or keep time in a loop. However, what on earth is a time crystal, which is an actual thing with real applications in the real world? Well, in this video, we're going to talk about the basic physics of a time crystal, which has surely nothing to do with time travel, as opposed to the one in Doctor Who. Ice has a crystalline structure, and if you put it in water, you sure know what will happen. The structure will collapse as the ice melts into water. That is because ice is cold and water is warm, and the temperature difference will lead to energy transfer until the whole system reaches thermal equilibrium, which is when the whole glass has a uniform temperature. However, what if a few moments later, the ice reforms along with the crystalline structure? Is it possible? That is the basic idea of a time crystal, where scientists theorize a crystal that not only repeats its molecular structure in the three-dimensional space, but also in the fourth dimension of time. The system will change in nature over time, but after a certain period of time, it will revert back to its original state, and then change again, and then revert back again. That is much like flipping a car back and forth in tenet, but at regular time intervals. However, you know by experience that it is simply not possible in the real world that we see. So where does a time crystal exist? Well, in the quantum realm. This is a diamond, and inside are millions of impurities called amphicenters, each with an electron spin which either goes up or down. Under normal conditions, these electron spins are aligned with each other and remain unchanged, but when we perturb the system with microwave pulses, the spins will flip up and down according to the driving frequency of the microwave. But this doesn't sound very exciting because it is much like moving a swing with our hand. The swing will of course move according to the frequency we swing it. But how about we change our frequency or stop moving completely? Will the system change or stop accordingly? Well, in a time crystal, it won't. What physicists found was the electron spin simply continue to flip up and down regularly at its own rhythm. It is much like a swing oscillating by itself at its own frequency, like something we see in a horror movie. Now you may wonder if a time crystal violates the laws of physics. How can it possibly repeat in motion without ever coming to rest? Well, it comes down to acknowledging time crystal as a new phase of matter. In solid, liquid, and gas, matter stops changing when it reaches equilibrium or the lowest energy state. A glass of ice water stops changing when it reaches thermal equilibrium. It is the way it is now. It was the same way 10 minutes ago. It will be the same way 10 minutes in the future. That is known as time translational symmetry, where the translation or the change in time should not affect the laws of physics. A stable system should remain stable over time. That is why after the ice melts, the H2O molecules should simply stay in random motion without reforming its crystalline structure. However, in a time crystal, things are a little bit different. As the first non-equilibrium matter, a time crystal can never reach equilibrium, and it breaks time translational symmetry by having H2O molecules that move non-randomly at a regular pattern over time. 10 minutes ago, it was ice, now it is water, 10 minutes later, it becomes ice again. This cycle of change may seem like perpetual motion like those we see on TikTok, which is impossible and forbidden by the second law of thermodynamics. That is because those perpetual motion machines actually absorb energy from a battery and dissipate energy through friction and heat. But the difference here with a time crystal is that it neither gains energy from the microwave pulses nor loses energy to the environment. Although constantly in motion, it is already at its lowest energy state, thus cannot lose more energy and come to rest. The repetitive motion of a time crystal is therefore known as motion without energy. And because entropy simply remains unchanged, it makes time crystal a possible state of matter that obeys the laws of thermodynamics. In February 2022, researchers created the first time crystal at room temperature that does not need to be isolated in a lab environment. Although a time crystal is yet to be widely used in modern technology, we can foresee time crystal being useful in improving atomic clock, which is essential for GPS. The steady spin-flip cycle can also help build stable quantum memories in quantum computers. Anyhow, time crystal is a new phase of matter that is real and does exist in the quantum world. And if you want to learn more about reversing time and reversing entropy in real life, make sure you check out my 2 other videos on the quantum physics behind tenet. Bye for now.